Sphere and a cuboid. Cuboid or side is x by 3, x and 2x. Okay, so then that's a constant. So s is equal to 4 pi r square plus 6x square, and that's a constant. One is a sphere and another is a cuboid of dimension x by 3, x and 2x. So now from this you can write what is r square is equal to s minus 6x square by 4 pi. R is equal to s minus 6x square by 4 pi the whole to the power 1 by 2. The combined area is maximum. Area of the sphere is 4 by 3 pi r cube, where you can substitute s minus 6x square by 4 pi the whole to the power 3 by 2 in r cubes place, because r is so much. 4 by 3 pi r cube plus the volume of the cube, which is L into b into h, which is 2 by 3 into x cube. Okay, because one side is x by 3, another side is x, another side is 2x of the cube. So this is what is the volume. You have to differentiate with this with respect to x. When you differentiate, 4 by 3 pi comes out, and this is 3 by 2 into s minus 6x square the whole to the power 1 by 2, which is root of by 1 by 4 pi is there, and chain rule will minus 12x plus, when you differentiate this will become 2x square. This one 2x square, 3x square, 3 and 3 get cancelled, 2x square. So now you can equate this with this. When you do that, it's 4 by pi whole to the power 3 by 2 will still be there. 4 to the power 3 by 2 is 8. Okay, this 2 and this 4 get cancelled, 3 and 3 get cancelled. That 8, this will become an 8, and 8 and 2 will get cancelled. 4 3s are 12. So you will get the pi, and the pi to the power 3 by 2 will become 1 by root pi. So you'll get 1 by 3 by root pi. Apart from that, you have an x, and you also have a root of s minus 6x square, and that can be equated to x square. So x and x get cancelled. Squaring both sides, 9 by pi into s minus 6x square is equal to 4x square. So s minus 6x square is 4x square into 9 by pi. You already know s from the first equation is 4 pi r square plus 6x square. 4 pi r square plus 6x square minus 6x square will be just 4 pi r square. Okay, where you know that now 4 and 4 get cancelled, and the pi goes up, right? Sorry. So the pi goes up when you cross multiply by 9. So it's 4 pi x square by 9. So 4 pi x square by 9, our pi and pi get cancelled, 4 and 4 get cancelled. So x is equal to 3r. So they got the condition. I'm sorry about the mistake, but I'm sure you understood. When you're doing it, do it along with me. Don't see the video. So now I have to do the double differentiation test, verify whether the volume is maximum or minimum, for which you take the differentiated value. Which is the differentiated value is here with the minus on this side. Okay, 3 by root pi into x into root of s minus 6x square minus 2x square, and this is the differentiated value, which you got to double differentiate d square v by dx square, where 3 by root pi is a constant. முதல்ல இருக்கிறது அப்படியே இது, ரெண்டாவது இருக்கிற டிஃபரன்ஷியேட்னா 1 by 2 into root of s minus 6x square. There will be already a minus sign here because it's minus 3. Okay, so then therefore it will become minus 12x, and so that will become a plus 12x chain rule, and this becomes a minus 4x. This is a differentiated value, and this, when you cancel all this will be a bigger value, and if you substitute s here as 4 pi r square plus 6x square, it will just be a 2 pi r, and when you substitute, this will be a 6x square minus 4x. X itself is 3r, so it will become 18 r square minus 8 pi r by a 2 pi r. 8 pi r is this is 22 by 7. So this will be 8 to 16, 8 to 16, 176 by 7, 7 2s are 14, 7 4s are 28, 7 5s 35. So it will be larger number, and you have to prove this to be negative. You have to ideally prove this to be negative. The double differentiation is getting difficult. So it's minus 3 by root pi முதல்ல இருக்கிறது அப்படியே இது, ரெண்டாவது இருக்கிறது டிஃப்ரென்ஷியேட் பண்ணால் and again it's minus 12x, so minus of minus will become positive and this will become, this itself is plus 4x, not this is a plus 2x square, sorry, so it will become plus 4x. So definitely when you take it in multiply, can you see it's positive? You don't have to do the calculations, just leave it like that. Can you see it's positive? Definitely. This is nothing but 4 pi r square plus 6x square, which will be just 4 pi r, 2 pi r eventually. So it's positive, that shows that the minima, the whatever value you got is minima, the minimum volume. Let's go to next question. The next question is about prove that the area of the right angle triangle, with a given hypotenuse, L is given. This is B and H, and so you know L square is equal to B square plus H square. You can write B square in terms of L square minus H square, and B is equal to root of L square minus H square. The question is about the area of the triangle is maximum. Area is half into base into height, half into base is L square minus H square into height, and you do this area, you don't want the root, so you can square both sides and call it as Z. It's L square minus H square into H square. It's differentiated. முதல்ல இருக்கிறது அப்படியே இது, ரெண்டாவது இருக்கிற டிஃப்ரென்ஷியேட் 2h plus ரெண்டாவது இருக்கிறது அப்படியே இது, முதல்ல இருக்கிற டிஃப்ரென்ஷியேட்னா minus 2h is equal to 0. So then 1 by 4 is totally common also. So L square minus H square into 2h is equal to 2h cube. H and h gets cancelled. Square 2 and 2 get cancelled. L square is equal to 2h square. Substituting it's here. L square is equal to 2h square is equal to b square plus h square. H square comes this side, h square is equal to b, h is equal to b, shows that it's isosceles. So that's the proof to show that this, which has got right angle triangle, which has got a maximum area, will end up being a isosceles triangle. So double differentiation verification. Where is the differentiated value? It's this. You have to take this and differentiate it again. You have a 1 by 4. The best thing is to take it inside and then differentiate. So it's 2 L square h minus 2h cube minus 2h cube. You have to differentiate this again. 1 by 4 into L square is constant minus 6h square minus 6h square. And you know that L square itself is 2h square. Substitute here, it will become 4L square minus 12h square, which shows that's definitely negative. And therefore whatever area you got is maximum area. Okay, that's the sum, beautiful sum. So next question, the next sum is another sum where the section of the window consists of it consists of a rectangle surmounted by an equilateral triangle, which means you're going to talk only about the perimeter. So if this is L, this will also be L and L. This will be breadth and breadth. This section of the window consists of a rectangle surmounted by an equilateral triangle. The perimeter is given to be 16. What is perimeter? It's 3L plus 2B is equal to 16. So you can write 1 in terms of the other. You can write B to be 16 minus 3L by 2. So then now the area has to be maximum. Amount of light coming in has to be maximum. L into B for rectangle's area plus area of an equilateral triangle is root 3 by 4 a square, which we can take it as L square itself. That's the area of the triangle. Area of an isosceles triangle is root 3 by 4 a square. So area of an equilateral triangle, what did I say? Area of an equilateral triangle is root 3 by 4 a square. So otherwise if you don't know, you know this is a and this becomes a by 2 and this becomes a height, and height is equal to root of a square minus a square by 4, which is root 3a by 2 becomes my height, and area is half into base into height root 3 by 2a, so root 3 by 4a square. So root 3 by 4 L square is my area of the equilateral triangle, and you can write L into B is 16. Let's split this up. It's 8 minus 3L by 2, doing a tuck here, plus root 3 by 4 L square. Now everything is in terms of L. We can differentiate. You can even take it in for convenience so that it's easy. So it is 8L minus 3L square by 2 plus root 3 by 4L square. And differentiating dA by dL, it will be equal to 8 minus 2 and 2 will get cancelled, 3L because 2L, 6L by 2 is 3L plus root 3 by 4 into 2L is equal to 0. So then you can 8 is equal to 3L plus root 3 by 2L. 8 is equal to L into 3 plus root 3 by 2 into L. So root 3 by 2. So then L therefore is 8 by 3 plus root 3 by 2. You can take LCM. It will be 6 plus root 3 in the denominator. This becomes 16. You can rationalize this 16 minus 3 by 6 minus root 3. A plus B into A minus B. A square minus B square. 36 minus 3 is 33. As 16 into 6 minus root 3. So something like that you will get for the value of L. Moment you get stuck, you go back and substitute in B. B is 16 minus 3L by 2. B is equal to 16 minus 3L by 2, isn't it? See it once again, minus 3L by 2. 16 minus 3 into L is again 16, which makes it 48, into 6 minus root 3 by by L you have a 33, so by a 33 by 2, something like this, and you have to take an LCM and see what will be the value of your of the breadth. So what will be the value of this? There's 33 and all coming. Okay, let me try this sum once again. Okay, so from here I'm going to try it again. So LB root 3 by 4 into L square. Yeah, L into B itself is 8 minus 3 by 2L plus root 3 by 4L square. 8L minus 3L square by 2 plus root 3 by 4L square. Differentiating, you get 8 minus 6L by 2, which is 3L, plus root 3 by 4 into 2L. Okay, correct. So then therefore 8 is equal to, when taking that to the other side, won't you get 3L minus root 3L by 2? I made a mistake, right? So L can be common, 3 minus root 3 by 2. So L therefore, okay, please correct it, guys. Therefore L is equal to 8 by 3 minus root 3 by 2. So L therefore is 8 by 16 minus 6 minus root 3. And that will be 16 minus, that will be my length, and substituting it in the breadth, I will get what will be the value of breadth? Breadth is equal to 8 minus 3L by 2. 8 minus 3L by 2. Breadth is equal to 8 minus 3L by 2, which is 8 minus 48 by 2 into 6 minus root 3. So when let me take an LCM, let this gets cancelled. 2 2s are 4, 4 2s are 8. 8 6 are 48 minus 8 root 3 minus 24 by 6 minus root 3 will be 24 minus 8 root 3 by 6 minus root 3. Here I can take out common, such as 8 is common. 3 minus root 3 by 6 minus root 3. Or 24 minus 8 root 3 by 6, or in other words you can keep it like this also, 24 minus 8 root 3 by 6 minus root 3. That becomes my breadth. Now what is that they want? Find the dimensions of the window. Yeah, when the amount of light is maximum. I don't know whether it's maximum minimum, so I still have to do the double differentiation test. You guys can do the double differentiation part. Which is the differentiated value? This is the differentiated value. Do it straight. This is minus 3. And do it from here. It's plus root 3 by 2. It's minus 3 plus 1.732. It's negative value, which shows that this is definitely a maximum. So that completes the sum. Beautiful sum. So let's go to next sum, which I think would be coming. An open box with a square base. The base is square, but otherwise it's not a square. It will be like something like this. Okay, but the base is a square. It's an open box, so you don't have to consider the top, even though it's a square. So this is A into A. at the base, but the height is h. So then if an open box with a square base is made up of a given quantity of cardboard of area c square, which means the surface area, if you're making it with an area of the cardboard which is c square, the surface area itself is c square. What is the surface area? It's the floor's area, which is a square, plus 4ah. 4 sides, ah are there. So then c square is equal to a square plus 4ah is the surface area, where c square is what is given, is a given area c square. So therefore you can write one in terms of the other. Now the combined, the volume has to be maximum. The volume is a dv by, okay, h or dA, I don't know. What is the volume's formula? Volume is a square h here. You need one in terms of the other. Let's write what is a square. C square, now you can't group a square because a square and a is there. You can only write what is h. C square minus a square by 4a. So a square into c square minus a square by 4a is the volume, and this has to be maximum. So let's cancel this a and this a. So 1 by 4 out, and take c square a minus a cube so that you can differentiate with respect to a. So 1 by 4 into c square, differentiation of c square a is just c square, because c square is a constant and a is the variable. 3a square is equal to 0. C square is equal to 3a square. C is equal to root 3a. Once you get c is equal to root 3a, if the open box with the square base is made up of a given quantity of cardboard c square, then show that the maximum volume, you're supposed to find the maximum volume. You got c substituted here, find the h, which is 3a square minus a square by 4a, which is 2a square by 4a. A and a get cancelled, it's a, h is equal to a by 2. So you got everything has to be got in terms of c, because c is a constant. So a is equal to c by root 3. A is equal to c by root 3, and h is equal to a by 2, which is c by 2 root 3. So you got everything in terms of c. So you can find the volume. Volume itself is a square h, which is c square by 3 into h is c by 2 root 3, which will become c cube by 6 root 3 cubic units, and that's what they're asking you to prove. The question is, if an open box with a square base is made up of a given quantity of cardboard of area c square, then show that the maximum volume of the box is c cube by 6 root 3 cubic units. That's all. So then now I have to do double differentiation test, which goes without saying, to see if this is maximum or minimum. So double differentiation must turn out to be negative. Where's the differentiated value? And take it and differentiate. C square differentiation 0 minus 6a, which is negative, which shows that this area volume that you got is for maximum. So that's another question which is very important. Next is, this question: if the sum of the lengths of the